In 3.4, we are going to discuss propagation of uncertainty from random error. Most propagation of uncertainty calculations that are performed deal with random error. The errors in the individual numbers will propagate through a series of calculations and in either of these relative or absolute fashion. And the most likely uncertainty in the result is not the sum of the individual errors. Some of these errors are likely to be positive and negative, and so we usually write them plus or minus. So remember, it's not the sum of the individual errors. I will show you how to do the math. For addition and subtraction, the uncertainty in the answer is obtained using the absolute uncertainties of the individual terms. This is a little bit of a confusing equation, but I'll show you how it works. We have the three values, 1.76 plus or minus 0.03, plus 1.89 plus or minus 0.02, and minus 0.59 plus or minus 0.02. Whenever you're doing these types of problems, you can always do this first part. That one's not hard at all. You just type into your calculator. It's the second part we need to figure out. We don't just add these numbers together to get a plus or minus 7. We actually have to plug them into this equation. What I mean by that is each of these represent an uncertainty that's going to go into the equation. So if there's, and this is only for plus or minus, this is only for addition and subtraction. You can always just combine them as long as they have at least addition and subtraction. The second multiplication or something else happens, you have to do a different equation. So we just plug in those values here and square them. And when we do that, after we square root it, we get 0.041. That 1 really doesn't matter because whenever we're dealing with uncertainties, we only care about one sig fig. So the answer is going to be 3.06 plus or minus 0.04. Notice that there's only one sig fig here, and the digit of your answer matches up with the amount of decimal places that your uncertainty is. So these match up. If there's 2 decimal places here, there's going to be 2 decimal places here. It's a little trickier for multiplication and division. So the uncertainty in the answer is obtained using the relative uncertainties of the individual terms. So then we would use this equation. Your uncertainty goes here, but your actual value goes here. And I'll show you an example on the following slide.